You must be wondering why I am taking this concept today. So I have mainly one reason for this. That is, this is the most asked question in the examination. And today's topic is integration using residues, and I'm going to use the contour integration. Now in this video, I'm going to evaluate integral 0 to infinity dx by x squared plus 9 into x squared plus 4 whole square using the residue theorem. So as you know that this is the contour. So this is the contour which is a semicircle with center 0 and radius r, and along with the real axis minus r to plus r, and the semicircle with center 0 and radius r. So we have to evaluate this integral. Now I am considering this in the solution as 0 to infinity, as it is in terms of x. I'm converting this, transforming this in terms of z as dx by z squared plus 9 into z squared plus 4 whole square, which is equal to integral c f of z into dz. So what is this c? C is a contour consisting of a semicircle CR of radius r together with the part of the real axis minus r to plus r. So this is the contour from minus r to plus r. So the direction here is from minus r to plus r, and again the closing thing is the semicircle CR with center 0 and radius r. So here, in order to find the integral, that is integral CF of z into dz, so we have two parts ready here. That is the integral from minus r to plus r f of x dx, as it is the real axis, and the next thing is CR. So integral CR is nothing but a semicircle with center 0 and radius r f of z into dz. So we have to find these two values and we have to substitute, and so that we'll be getting the total integral c f of z into dz. So here what is our f of z? So f of z is nothing but 1 by z square plus 9 into z square plus 4 whole square. So now I am going to use the residue theorem. So before using the residue theorem, so we have to find the poles. So our f of z is ready as, so here is f of z, that is 1 by, so this is 1 by, this is z squared plus 9 into the next one is z squared plus 4 whole square. So first of all, what we have to do? So in order to find the poles, we have to equate the denominator to 0. So what is the denominator here? That is z squared plus 9 into this is z squared plus 4 whole square is equal to 0. First of all, if I equate z squared plus 9 to 0, see what happens here. So z square is equal to minus 9 and z is equal to root over minus 9 and z is equal to plus or minus 3. So we got two simple poles, that is minus 3i and plus 3i. And next thing here is, if I equate this one, that is z squared plus 4 whole square to 0. See, first of all, if I equate z squared plus 4 is equal to 0, so z square is equal to minus 4 and z is equal to root over minus 4 and z is equal to plus or minus 2i. Here, there are two poles here, that is minus 2i and plus 2i, which is of order 2. So we got these poles, that is z is equal to plus 3i plus or minus 3i, which is a simple pole. A simple pole we got. And the next thing here is z is equal to plus or minus 2i is a pole of order 2. Is a pole of, this is order 2. Now we have to check whether these poles are within or on or outside the given contour. So what is the contour here? The contour is nothing but the semicircle. So this is a semicircle with center 0 and radius r. So this is center 0 and radius r, and this is the limits are from minus r to plus r. So this is x-axis and this is y-axis. And see, I'll check whether these two are inside or on or outside the given contour. So plus 2i is within this one. So this is plus 2i and this is plus 3i. So here if you observe, this is I, this is minus 2i and this is minus 3i. So these two are outside the given contour and plus 2i and plus 3i are within the contour. Therefore, for the interior poles, we have to find the residues for applying in the residue theorem. So we have to find the residues for the pole of order 2, that is z is equal to 2i and z is equal to 3i is a simple pole. First of all, I am finding a simple residue for the simple pole. Z is equal to, this is 3i. For a simple pole, what is the formula here? That is limit z tends to 3i. This is z minus 3i into f of z. So what is our f of z? So f of z is very clear as limit z tends to 3i. I'll show you. That is z minus 3i into c here. This is 1 by, so this is 1 by z square plus 9. This is z square plus 9 into this is z square plus 4 whole square. So this is our f of z. So first of all, this will be limit z tends to 3i. This is z minus 3i by, so this can be split into, this is z plus 3i into, the value here is z minus 3i into this value is z square plus 4 whole square. Now after cancelling this one and substituting in place of z as 3i, so this will be 1 by, this is 3i plus 3i into, this is 3i whole square plus 4 whole square. So the value here will be, the value here will be 1 by 6i times of, this is minus I plus 4 whole square. So this is nothing but the residue of f of z for the interior pole z is equal to 3i. So the thing here is, so this will be 1 by 6i times of, this is minus 5 whole square. So this is 1 by 6i into minus 5 whole square is nothing but 25. So this will be 150. So this is 150 into I. So this is a residue value for the interior pole z is equal to 3i. So for the interior pole z is equal to 3i. So we got the residue value as 1 by 150i. And the next interior pole here is 2i. So 2i is a pole of order 2. So for pole of order 2, there is a formula here. So the next interior pole is z is equal to, see here, z is equal to 2i. For the interior pole, see here, the residue of f of z for the interior pole z is equal to 2i, which is of order 2, is nothing but, see, this is m minus 1 factorial into, this is d by dz power, this is m minus 1 into here, limit z tends to z naught, this is z minus z naught power m into f of z. So this is the formula. So in this formula, what is our m? M is nothing but the order. So this is of order 2 and z naught is nothing but the pole value, that is 2i. So after substituting, this will be residue of f of z. At the interior pole, z is equal to 2i is equal to 1 by m is equal to 1. This is 2 minus 1 factorial into, this is limit z tends to, z naught is 2i. This is d by dz power m minus 1. So this is 2 minus 1 into z minus, what is z naught here? This is 2i square into f of z. So f of z is nothing but, see, I'll show you, z square plus 9 into z square plus 4 whole square. So this is z square plus 9 into this value is z square plus 4 whole square. And now see here, this is 2 minus 1 is 1 factorial and this will be limit z tends to 2i. This is d by dz times of, this is z minus 2i into, see here, this is z square plus 9 into, so if I cancel this one, this will be, see here, this is a square, this will be z plus 2i square and this is z minus 2i square. So now I can cancel this one. And see, the most important thing here is we have to derive for one time and then again substitute z is equal to 2i. So this is limit z tends to 2i. The derivative of this one is, see here, this is z square plus 9 into z plus 2i whole square. Clear? Now I am going to solve this one. So before solving this one, so you need the derivative of 1 by x. The derivative of 1 by x is nothing but this is minus 1 by x square. So this is minus 1 by x square. So this will be, I'm showing you, the derivative of this one is limit z tends to 2i. So this will be minus 1 by, this is z square plus 9 whole square and this is z square plus 2i whole power 4. And again we have to make a derivative for the denominator. For the denominator, if I make a derivative, see, this is of the method UV rule. So this is u and this is v. See, this is u and this is v. So if I close it, so in the numerator, this will be, so this is minus 1 times of. So if I make a derivative, this will be 2 times of this is z square plus 9, and I have to leave this one. This is 2z into, this will be z plus 2I power 4. Clear? So I made a derivative for this. So this will be 2 times of, no. See here. So this is the derivative which we have to make. This will be, see, this is limit z tends to 2I. The derivative for 1 by x is nothing but minus 1 by. So this is minus 1 by x square. That is z minus 1 whole square and z plus 2I power 4. And again for this we have to make a derivative in the numerator. So this will be 2z into. So this is u. I am making a derivative for u and leaving this one. That is z plus 2I whole square. Clear? And the next one is, this time I have to leave this one. U I am leaving. For v, the derivative here is 2 times of z plus 2I. Clear? And now see here, after taking z plus 2I common from the numerator, this will be limit z tends to 2I. This will be z plus 2I if I take common. So there is already minus here. This is 2z times of, this is z plus 2I. And if I take common, what remains here? 2 times of z square plus 9 remains. By this value will be z square plus 9 whole square, and this is z plus 2I power 4. So if I cancel for one time, how many times remains? 3 times. So this will be limit z tends to 2I. This is minus 1 times of. So if I multiply, this will be 2z square plus 4zi. And if I again multiply, this will be 2z square plus 18 by, so this will be z square plus 9 whole square, and this is z plus 2I whole cube. Now after deriving for one time, so this is 2z square and 2z square. So this is limit z tends to 2I. This is minus 1 times of, this value is 4z square plus this is 4zi plus 18 by, this value is z square plus 9 whole square plus z square plus 2I whole cube. And now if I substitute z is equal to 2I here, this will be 4 times of, this is 2I whole square plus 4 times of, this is 2I into I plus this value is 18 by, so 2I. So this will be 2I whole square plus 9 whole square, and this is 2I plus 2I whole cube. And the value here is minus of, this is 4 into, so this is 2 square 4, this is minus 4 plus 8 into I square is minus 1 plus 18 by, so this value is minus 4 plus 9 whole square, and this is 4I whole cube. Clear? So this will be minus of, this is minus 16, this is minus 8 plus this value is 18 by 5 square, this is 25, and 4 cube, this is a 64, and I cube for I square. I square, this is minus 1, and again I. So as you know that I square value is minus 1, I am substituting here. I square is equal to minus 1, and what comes next? So this value will be minus, so this is minus 24 plus 18 by, this is 25 I square, this is minus into 64 I. And see here, and the next thing here is, this will be minus of, this is minus 6 by, this value is minus 25. So this is minus 25 into 64I. So this will be minus of minus plus 6 by, this is minus 25 into 64I. So if I send minus to the numerator, this will be minus 6 by 25 into 64I. So if I cancel in two tables, so this is 3 and this is 32. So this will be minus 3 by, so 25 into 32 is around 800. So this is 800I. So we got the residue value of f of z for the interior pole z is equal to 2I, which is of order 2. So for the interior pole z is equal to 2I, we got this value as minus 3 by 800. Now which theorem we have to apply? So we have to apply the residue theorem. So according to a residue theorem, So this is our residue theorem. So according to our residue theorem, so integral c f of z into dz can be written as, this is 2 pi I into sum of the residues of the interior poles, sum of the residues of interior poles. So what are the interior poles here? That is plus 2i and plus 3i. So this will be integral c f of z into dz value is equal to, this is 2 pi I times of. So the first interior pole here is, the first interior pole here is plus 3i, which is 1 by 150i. So this is 1 by, this is 150i, and the next interior pole here is this, that is minus 3 by, that is 800 into I. So here these two are the interior poles. So if I calculate this one, this is minus 2 pi I times of. If I take 2i common from this will be 1 by 72. This is minus 3 by, if I take 2 common, this will be 400. 400. Now if I cancel these two, what remains? This is pi times of. So if I take LCM, this will be 1200. So 75 in 16 times, and 400 3 times. 3 3s are 9, and therefore we got the value as a 7 by, this is 1200. So this value is a 7 pi by 1200. So which value it is? Integral c f of z into dz. So here is a clarity for you. So we got the integral value, the total integral value f of c into f of z dz value as, this is a 7 pi by, the value here is 1200. But there is a logic here. So what is this one? So c is nothing but the contour. So which contour it is? So this is the contour from minus r to plus r. So this is the direction, and the next, the closing thing here is the cr, so which is a semicircle with center 0 and radius r. Now see here, this is x-axis and this is y-axis. Now the total integral I am telling you. So integral c will be split into two parts, that is minus r to plus r. This is the real axis f of x into dx, and plus the semicircle, this is f of z into dz value is equal to, the value here is 7 pi by, the value here is 1200. Now as r tends to infinity, as r tends to infinity, so what happens to this? This will be minus infinity to plus infinity. So I'm transforming this r to infinity, that is f of x into dx plus, this is cr into f of z into dz value is equal to, this is 7 pi by, this value is 1200. See what happens to this f of z into dz. See clearly, as r tends to infinity, what happens to this cr? This is f of z into dz value will be, what is our f of z value? So f of z value is very clear as this one. See, I'll show you. The clarity which I am giving today is z square plus 9 into, this is z square plus 4 whole square. So if I take z is equal to r into e power I theta. See here, if I apply modulus, this will be modulus of e power I theta, that is mod z value will be r times of, this is cos theta plus I sin theta. Clear? So mod z value is equal to r times of root over, this is cos square theta plus sin square theta, which is equal to 1. Therefore I can write mod z value as r. And the next thing here is, so dz is also there. So here there is dz. So for dz value, what we have to do? So we have to make a derivative again for z is equal to r into e power I theta. So dz value is equal to r into, if I make a derivative, this will be e power I theta, I into d theta. Again, if I take modulus, see here, r times of modulus I times of e power I theta into d theta. So this is mod dz value is equal to r times of I into e power I theta is nothing but cos theta plus again I sin theta into, the value here is d theta. D theta, clear? If I take modulus, then see r times of, if I send I inside, that is I cos theta minus I square, this is minus, this is sin theta into d theta. For modulus, what we have to do? This is r times of root over, this is cos square theta plus minus a sine theta whole square into d theta. So obviously cos square theta plus sine square theta is 1, root 1 is 1. So mod z value can be written as r into d theta. Clear? So I'm giving you a clarity and there is no need to write here in the examination. See, f of z into dz value is very clear, as this is dz by this is z square plus 9 into this is z square plus 4 whole square. So in place of dz I'm writing, if after taking modulus, this is r into d theta. So here in place of z I'm writing r. This will be r square plus 9 and this will be r square plus 4 whole square. So as you can see, there are so many r's left over here. So if I take r square common, this will be 9 by r square. If I take r power 4 common, this will be 1 by 4 by r square whole square. So after cancelling, so there are r's left in the denominator, as you tend r to infinity, so this will be 1 by infinity, which is 0. So this is nothing but integral cr f of z dz value is 0 as r tends to infinity. So this is what I'm writing here. So this value, as r tends to infinity, the value here is, as r tends to infinity, this value is going to become 0. Therefore integral minus infinity to plus infinity f of x dx plus a 0 value is equal to, this is a 7 pi by 1200. So what is our thing? This is minus infinity to plus infinity. What is our f of x? F of x value is nothing but this is x square plus 9 into the value here is x square plus 4 whole square, value is equal to 7 pi by 1200. So this is how we have to solve. Thank you so much for staying till the end, and if you really like this video, you know what to do. Please pass it on to your friends, siblings, and as you all grown up children, and you can easily catch up my point. And please practice. There are so many videos uploaded in the playlist. Have a look at those and it will be very easy for your preparation. So any problem, any solution will be available in this channel, and avail those. Thank you so much.